next part will be to explain really the theory how to select really the best and proper fitting 7SS85 busbar protection device to your substation, to your requirements. Before I will start, just one wrap up from our questions I have answered. We had a short discussion, and maybe I understand these questions about whether it will be possible to replace line differential protection by busbar protection. This is of course not possible. This won't be possible. That's this I have explained. But of course, what is possible, as each modular Cybertech 5 device can be used as a bay unit for the distributed busbar protection, and so of course you can use a line differential protection device, a 7SL8687, with the integrated line differential protection, and then you can integrate it really in the functionality of the bay unit of the distributed busbar protection. This is possible to take a line differential protection device as a bay unit for the distributed busbar protection, and then you have the line differential protection. Maybe this question was more in this direction. Okay, let's start. Device selection theory. The practical part will afterwards Nina show to you. Before I will go into details how to configure the correct device, for a small wrap up, what are the advantages and what are the disadvantages of the three basic device types of the centralized busbar protection, of the IEC 61850 compliant distributed busbar protection, and the full distributed busbar protection, the successor of the 7SS52. Let's start with the centralized busbar protection, the 7SS85 Thunderbird. What are the advantages? It's very easy to engineer. Dixie 5 during this engineering brings us really enhanced consistency checks. So it will be nearly impossible to bring a wrong configuration to your device. As it is a centralized busbar protection, you have only one device, only one CPU instead of several CPUs, instead of several devices. It's cost optimized. So centralized busbar protection is mostly, in each case, also the best one in case of price. Up to 20 CDs are possible. This may be a disadvantage compared to the distributed busbar protection, but compared to really all other competitors of busbar protection devices, this is really a big advantage because we are really the only vendor which allows a centralized busbar protection with up to 20 CDs, 20 current measuring points, means 80 current inputs within one device. We can deal with up to 6 bus zones. And already said, it's price optimized due to a low hardware effort. What may be some disadvantages? Now we come a little bit also to the questions I said I will answer during my next part of this presentation. It may be a high wiring effort because all the binary inputs, all the cables of the binary inputs, of the binary outputs, of the CDs must be concentrated at one device. So it's a quite high wiring effort. Here, very important, if we have a large air-isolated substation, we will have a risk of a high CD burden because these long cables from this decentralized systems from one bay, which may be 200 meters away from the center unit, you need a very long cable, a very long wire, and this leads to a high CD burden. And this high CD burden can lead into an earlier saturation of your CD. So the centralized busbar protection is only suitable really mostly for GIS substations. Suitable for compact substation, as already said. the IEC 61850 compliance solution. Advantages, fully integrated. It can be fully integrated in the overall IEC 61850 process. A big advantage, also in contrast to the 7SS85CU, that the integration of third-party merging units means merging unit from GE or ABB or anything else can also be used as a bay unit for the distributed busbar protection. We can use this hybrid setup, as Nina already has explained. Hybrid setup, once again, means a combination of both distributed approach and also a centralized approach. Typically, we are using a distributed busbar protection, locate the 7SS85 device in a coupler, and we make a centralized wiring to the coupler, to the 7SS85, whereas all the feeders will be assigned by the distributed approach. And this is a common general advantage in our 7SS85 Cyprotec 5 distributed busbar protection. Each Cyprotec 5 device can be used as a merging unit for the distributed busbar protection. For example, also an 7SL8, 7SL86, 7SL87, a line differential protection, but also distance protection, transformer protection, each device which is in the Cyprotec 5 portfolio. A little bit the disadvantages. It may be a quite complex and fault-prone engineering. Maybe not so much the assignment of the current information to the device, but to do all the disconnector positions of the several disconnectors, of the positions of the circuit breakers, the trip commands, and wiring this via a goose engineering. It's not so easy job. It can be done. It's not complicated, but the engineer has to be very concentrated. The setup is only for a maximum of 24 CDs, a maximum number of 24 bays. And as we are using the same device as a centralized busbar protection, it's also limited to up to 6 bus-ons. Let's come to the 7SS85CU, the fully distributed busbar protection. It's very easy to engineer, especially in contrast to the IEC 650 compliance solution. It can also you can also use very enhanced consistency checks. This is associated, of course, a lot of that it's not, let's come in the same step to the disadvantage, that it's not, you can't use third-party merging units for the 7SS85CU solution. And this comes a lot with this enhanced consistency checks, which are, of course, not possible if we are using a device from a third party. If we are using a merging unit from GE, a merging unit from ABB, they have their own engineering tools, and it's not possible to integrate them with the same consistency check like our Cyprotec 5 merging units. Up to 48, beginning with 9.40, which will be released hopefully during this week. There will be 48 CDs possible, up to now only 45 CDs. There are up to 20 bus-ons possible with the 7SS85CU solution, and the same like in the IEC 61850 compliance solution, you can use each modular, I forgot this on the slide, very important, you can use each modular Cyprotec 5 device as a merging unit, as a bay unit for the distributed busbar protection. How could really and way a decision matrix be for the correct device selection to select the correct type of 7SS85 busbar protection? The first question is, what are the number of CDs? What are the numbers of measuring points? Are there higher or lower than 20? And what is the number of independent bus zones? Are they higher or lower or 6? If you have more than 20 CDs, and if you need more than 6 bus zones, there's no doubt about it. The only solution could be to use a 7SS85CU. Sometimes you may have the possibility to split the substation. If you have a sectionalization coupler, you can split it into 2 systems. But typically, in generally, you should use more than 20 CDs, more than 6 bus zones. Please use the 7SS85CU solution. Then next questions. If you are below 20 CDs and if you are below 6 zones, then you have to ask, is my substation a compact, small, gas-isolated substation, or do I have a large air-isolated switchgear? If we have a compact GIS, okay, we can deal with a centralized busbar protection approach. If it's a large air-isolated switchgear, I have already explained, a very big substation, you need a long of cable, a long distance of wiring of the primary CDs with the CDs in your device, which means a high burden of the primary CD. And such a high burden of the primary CD could lead into an earlier CD saturation, which would risk a wrong tripping in case of an external fault. This is very important. Okay, if we have a large air-isolated switchgear, so that means we need for sure a distributed busbar protection, and we can ask more the questions, do we want to use a hybrid configuration? Do we want to use a mix of a centralized busbar protection and a distributed busbar protection? If yes, we should use the IEC 650 compliant solution. If not, then you may ask, okay, does the customer or do you want to use also third-party merging units, maybe also from NARI, GE or anything else? If yes, you have also only the chance to use the IEC 650 compliance solution. If not, and you want to have an easy engineering, you should use the 7SS85CU solution. Or, of course, you can every time shorten this decision matrix. You are the user of a 7SS52. You are very you loved your 7SS52 systems and you want simply a successor of the 7SS52, and then you can go directly the same approach. Okay, I want to have a successor of the 7SS52, and then you will immediately go and use the 7SS85CU solution. Okay, let's go more into the details. We have here on the one side the 7SS85, the centralized, with certain significant features from 9 and from A to E. And we have new types. We have the 7SS85CU solution with also special significant features. This you will see on the right side on the slides. So let's go more into the details. Let's explain a little bit what different types of 7SS85s are available. Let's start on the right side. We have the significant feature 9 and A, B, C, D, E. These are the significant features for the centralized busbar protection and also for the distributed IEC interoperable IEC 650 compliance solution. We have here the significant feature 9. Which can deal only with one zone. So only one bus zone, only one single bus. We have A, 2 zones, 2 independent single buses, and we have B, which has also 2 zones, but it has a disconnector image. This means with significant feature B, we can deal also with one double bus. And then we have the C, which is also without disconnector image. So this means 6 independent single buses. We have the significant feature D, which means 6 zones with disconnector image. This means this would allow a triple bus bar with a sectionalizer inside, for example, or a double bus bar with a sectionalizer in a transfer bus or anything else. A very special significant feature is the significant feature E, which also allows 6 zones and has a disconnector image, but in this very special functionality, you have only the circuit breaker failure protection available. You don't have a busbar differential protection. This is a special requirement to use a busbar protection device, the 7SS85, to use only the disconnector image of the busbar protection device to clear the associated bus zone in case of a circuit breaker failure. And also you see here how many bays in the distributed approach you have available. With significant feature A, we have 4 bays included. With C and D and E, we have already 6 bays included. The hardware variants are only, which you will see on the right of the slides, the hardware variants. Oops, now I don't see any slides anymore. Now I see it again. The hardware variants are just an, how to say, successions of a starting point of your correct configuration, of your correct hardware configuration. So we will come to it later. And last but not least, we have the significant feature for the fully distributed solution for the 7SS85CU. These are the significant feature F, which is for only 6 zones. Once again, no disconnector image available. And okay, G, the CU for up to 20 zones. Not very common, this issue. Very seldom to have really 20 zones without a double bus bar or triple bus bar. We have once again CH, the CU for 20 zones disconnected and circuit breaker failure protection only. That's the same what I have explained with the significant feature E for the centralized busbar protection. And you have the significant feature for the 7SS85CU with a disconnector image, the J with 6 zones, and the K, the biggest one, with 20 zones and disconnector image. And very important, with the 7SS85CU solution, it is always a distributed approach. It's no way to use it as a centralized busbar protection. There are no bays necessary and therefore also no bays included. Okay, finding a correct device configuration is split into 3 parts. First part, the 7SS85 centralized, find a correct device configuration for the 7SS85 centralized busbar protections. Next, of course, will be find the correct configuration for the 7SS85CU, and finally find, which is more or less a combination, find the correct devices for the IEC 62150 compliant distributed solution. The most complicated, because the most things are new, will be the explanation of the centralized busbar protection. But if you know the centralized busbar protection and how to find the correct configuration for a centralized busbar protection, it will be quite easy to find the correct configuration for the other ones. So let's concentrate in the first step to the centralized busbar protection. What questions have to be answered? How many bus sections must be considered? Is a disconnector image necessary? I will explain it later in detail. How many measuring points and how many bays? This is quite often similar, but can be quite often also different. Do we need a circuit breaker failure protection? Do we need end-fault protection? and how many binary inputs, binary outputs are necessary to handle the whole configuration. Let's start with the bus sections. Double bus bar here is a small example. It's a good idea to remember this example very well, because exactly this example later Nina will configure on a practical case, in a practical exercise in the Cyberdeck 5 configurator. Here we have a double bus bar with a coupler. How many bus sections do we need? 2 bus sections. You can see here we have the double bus bar. Here's bus bar 1, bus bar A. Here is colored in blue. And the bus bar B or bus bar 2 is colored in red, I guess it is. And as it is a differential protection, the split between bus bar A and bus bar B will be done in the coupler, and really the split of these 2 bus bars will be exactly at the current transformer. And here you could also see already an example, a coupler with only 1 CD. 2 CDs would be also possible, but here we have an example with 1 CD only. So here, example, how many bus sections do we need? In our example, now we need 2 bus sections. Disconnector image. Do we need a disconnector image? That's maybe sometimes for somebody who comes from the 7SS52 and is new to the 7SS85 a little bit different. When do we need really a disconnector image in our device, and when can we buy the cheaper one without disconnector image? So, depending on the disconnector status, the current will be assigned according to the according measurement system. If you see the feeder on the left side, the busbar disconnector to busbar B is closed. So this means this feeder current will be assigned to busbar B. On the other case, the feeder on the right side of the coupler is signed in blue. Here the disconnector to busbar A is closed. So this current will be assigned to busbar A. This means we every time need a disconnector image when a feeder current can be assigned to different bus zones, to different bus sections. So don't look, if you want to answer these questions, don't look if you have any couplers. Couplers doesn't matter. Do we have one feeder, and one feeder is enough, where with disconnectors we can assign the current of this feeder to different bus bars, to different bus sections. In this case, we need a disconnector image. So in our case, don't forget, we need a disconnector image. Okay, the disconnector status will be recorded by auxiliary contacts. We will this also explain in detail a lot in our second tutorial. And we have, like in the 7SS52, this not open is closed treatment. This means also that especially in the sensorless busbar protection, where sometimes we may not have so many binary inputs, that also a binary input, that also one binary input may be sufficient to make this not open closed treatment. But it's very important, if we are using only one binary input, we have to use a normally closed contact of the disconnector, which gives us a clear signal whether the disconnector is high or not. Whether the disconnector is open or not with a high signal. Of course, only in the case we have 2 binary inputs, we can really make a supervision of the transition time, and we can also making if we have a runtime error or anything else. But it's important for our example here, just to make some exercise and to state it's possible in principle, we will use only one binary input for the disconnector position. N-fault protection. We have to know whether we need an N-fault protection or not in case that we have to pay function points for the N-fault protection functionality. The N-fault protections, once again, outlook to our next tutorial. The N-fault protection will shift the protection range from the current transformer to the open circuit breaker. And this depends on the location of the CD, on the location of the circuit breaker or the location of the CD relative. It prevents from an over or an under functionality. That's for the feeder bay, and in the feeder bay it also gives us a transfer signal to the other end of the line to clear the fault from the other end of the line. In a coupler bay, the N-fault protection will also protect, in case of an open circuit breaker, the area between the current transformer and the open circuit breaker. So this means also in this case we should consider one N-fault protection in each feeder bay, and very important, also one N-fault protection for the gray zone protection in the coupler. Okay, we have learned now, we have this example of a double busbar with 4 feeders and one coupler with 1 CT. And the proposal is so we can use a significant feature B, which deliver us 2 zones. That's enough for our example. And also brings us a disconnector image. We need also a disconnector image. And very important, we have 4 bays inclusive together with the significant feature B. And it's also the proposal to use standard variant 2, which also brings us 16 current inputs. Here we have really the single current inputs. So the 16 in this case means we have 4 bays, 4 measuring points included, and binary inputs and binary outputs. But to make it also obvious that it's only a proposal, you can start also with the standard hardware variant version 1. And we will do this in this case. We will start with significant feature B. We will select a 7SS85 with significant feature B. And we will start our configuration with a hardware variant version 1, which brings us 12 current inputs, which means 3 measuring points, all in all 13 binary outputs and 15 binary inputs. Okay, how many we need all in all? Let's count. Bays, we have already 4 bays inclusive, so we can cover with these 4 bays the 2 feeders left to the coupler. We can cover the coupler bay, and we can cover 1 feeder bay right to the coupler. So we need 1 additional bay. So we have to bay by function points 1 additional bay. That's this red one. CDs, we need all in all 5 CDs. So we have already 3 CDs with the hardware variant version 1. So we have to take care that we have 2 further CDs. Oops. Let's count the number of necessary binary inputs. So we have, what binary inputs do we need? We need the circuit breaker close command. That's very essential and important for the N-fault protection to bring really right in time when the circuit breaker will be closed, the current back to the measurement system. So that's very essential. Once again, will be explained more in detail together with the N-fault protection. But really it's very important not to forget to use the CB close command for the N-fault protection. So if there is any wrong trimming of the busbar protection, And so typically, as a PLM for busbar protection, typically 1 or 2 times a year, there's a high upset in our organization, wrong tripping of a busbar protection. And nearly at every time, it was a reason that they forgot they have end-fault protection, they have an external fault, they have an automatic reclosing, and they forgot to use the CB close command, and you have a wrong triggering of the busbar protection because the end-fault protection was deactivated too late because of the missing CB close command. The auxiliary contacts of the circuit breaker, you need, okay, I forgot the CB close command. Here, 1 binary input is enough, both for the feeders and for the coupler. The circuit breaker auxiliary contacts for the position of the circuit breaker, which is necessary not for the disconnector image, but for the end-fault protection. We need 2 binary inputs in the feeder, and in the coupler 1 binary input may enough, because here the coupler current is not part of the checkzone anyway, so here the security requirements may a little bit lower. We need 1 binary input for each feeder to activate the circuit breaker failure protection in the feeder. Typically, you have no external started circuit breaker failure protection in the coupler, so we don't need it. And for the disconnector image, we have 2 busbar disconnectors in each feeder. And as we said, just to say that it's possible, so we are using only 1 binary input in this example. So we need 2 binary inputs per feeder for the 2 binary inputs per feeder for the busbar disconnectors. Binary outputs. How many binary outputs do we need? We have this transfer signal from the end-fault protection to send a trip signal in case of a fault between the circuit breaker and the current transformer to the other end of the line. So we need 1 binary output, typically not necessary in the coupler, because you have no other end of the line in a coupler. And typically for the circuit breaker trip command, we are using 2 binary outputs. So in total, we need for this configuration 28 binary inputs and 40 binary outputs. Function points, already said. End-fault protection in each feeder and also in the coupler. So 5 points here in the sum. Circuit breaker failure protection, here we assume only a 3-pole circuit breaker failure protection. This means 15 points in each feeder, no function points in the coupler. And for the additional bay, we need 50 function points for this 1 additional base. Already 4 bays are included, as you remember, with significant feature B. So in total, 28 binary inputs, 14 binary outputs, and 135 function points. The next function point class will be 150. In the meantime, of course, you could also use, together with the function point manager, the class hash functionality, and then you can work exactly with the 135 function points. So, this you can see here with hardware variant version 1, we can more or less cover the 3 feeders and the 1 coupler. And to have enough binary inputs, enough binary outputs, also for the missing 2 feeders on the right, we extend the configuration each we extend the configuration with 2 IO201. Then we have the configuration really of 5 measuring points, of 31 binary inputs, and of 25 binary outputs, which is yes, absolutely sufficient for this small double busbar. Okay, next slides I really like, because it gives also a little bit to you the possibility to check whether you have understood all the things I have tried to explain now. Here we have a small configuration. We have a single bus with a sectionalizing coupler in between. So check it by yourself. First questions, how many bus zones do we need? I give you every time a little bit time. Okay, the answer is of course 2. One bus zone left to the sectionalizing coupler, one bus zone right to the sectionalizer. Do we need a disconnector image? Please remember, when do we need a disconnector image? We need a disconnector image when it is possible via disconnectors to assign a feeder current to different bus zones. And this is definitely not possible here. We have no busbar disconnectors at all. Each feeder is directly assigned to a dedicated bus zone, so we don't need a disconnector image in this case. How many bays do we need? Will be interesting. There are 8. Let's count. See 4 feeders on the left side of the coupler, the 3 feeders on the right side of the coupler, and for the complete coupler, even if it's a coupler with 2 CTs, we need only 1 bay. So all in all, we need 8 bays in this example. How many CTs do we need? Of course, it's 9. We have 8 bays, but for the coupler bay, we need 2 CTs, so we need 1 CT more than bays, so we need all in all 9 CTs. Okay, now it will be interesting. How many will give here the answers correct? That's a double busbar. I see some couplers. And I see also sectionalizing couplers. I see a sectionalizing coupler. I see a sectionalizing disconnectors. So first, how many bus zones do we need? I guess this hopefully is quite simple. It's 4. So 2 bus zones on the left side of the coupler and 2 bus zones on the right side of the coupler. Do we need a disconnector image? Once again, we have busbar disconnectors, so the feeder currents could be assigned to different bus zones. It could be assigned to the upper busbar or to the lower busbar. So it's quite clear, we need here a disconnector image. Number of bays. Now I give a little bit time. So please count the number of bays. Okay, there are 11. I guess quite a lot of you may answer also we need only 10 bays or we need only 8 bays. So let's count in detail. So here we have 3 bays. Here we have 4 bays. That's 7, 8, 9. And now it will be interesting. That will be 10. That we need 1 bay, 1 dedicated bay for this coupler, for this real coupler with 1 circuit breaker and with 1 CT. But we need also 1 additional bay for the sectionalizing disconnector. If you have more sectionalizing disconnectors, you can use the same bay, but you need at least 1 dedicated bay only for the sectionalizers. How many CTs do we need? I think that's quite simple. You simply have to count the number of current transformer symbols on the single line, and that's 10, of course. Exercise 3 may be also quite interesting. First of all, how many bus zones do we need? I think this could be answered quite fast. That's, of course, we need 2 bus zones. Do we need a disconnector image? maybe quite interesting because it looks a little bit like a double bus bar, because we have one bus zone, one bus section on the top, and below we have a further bus sections. But please look carefully. The feeder, I can't find any CD which could be assigned to different bus zones. So we need no disconnector image. We have no busbar disconnectors. It's no disconnector image because you can't switch CDs by disconnector positions to different bus zones. Numbers of bays. Look carefully. It looks a little bit like, and from customer point of view, it looks like 5 bays. But here we need really 10 bays, because we need really 1 bay per pair of CT and circuit breaker in each bay. So we have here, from customer point of view, the two bays will be combined to only 1 bay, but for our busbar protection, we need really 10 bays. Number of CDs, okay, that's easy. These are 10 current transformers, 10 measuring points. Last exercise, that's a so-called circuit breaker and a half scheme. Maybe also interesting to look about it. How many bus zones do we need in a circuit breaker in the half scheme? So that's a circuit breaker in the half scheme with so-called 5 diameters. And the number of bus zones, of course, it's only 2. So you have 1 bus zone on the top and you have 1 bus zone on the bottom. Do we need a disconnector image? So you have to look carefully. So also here you can't assign any feeder current transformer to different bus zones. You can't assign this feeder current transformer either to the bus zone on the top or to the bus zone on the level. So we don't need a disconnector image. Numbers of bays. So we have 5 diameters, but it will be split into 2 independent bus zones. So we need in total 10 bays. So 5 bays directly assigned to the upper bus bar and the 5 bays assigned to the lower bus bar. And the number of CDs here also quite easy, is also 10. So I hope you were all quite successful answering my short exercises. Now I have completed to explain really the centralized busbar protection and how to find the correct device type of a centralized busbar protection. But what's about a distributed scheme? So we have to answer the same questions. How many bus sections must be considered? These questions is necessary to find the correct type of the 7SS85CU. It's not necessary to find the correct form of the bay unit of the merging unit. Do we need a disconnector image? The same as before. Also necessary only to find the correct way in the 7SS85CU. How many measuring points and bays will be needed? As already said, I have here, it's striked out, the end base is striked out, because in the fully distributed approach, it's not necessary anymore to count the number of bays. So you only have to count the number of measuring points, and of course the number of measuring points, will be located and must be located in the bay unit. Do we need circuit breaker failure protection? Also this question is necessary in the bay unit. And also the end fault protection must be located in the bay unit. So all in all, all backup protection functionality must be located in the merging unit, must be located in the bay unit. And of course, the bay units, for the bay units also it must be answered the questions, how many binary inputs do I need, how many outputs do I need in the bay unit. Okay. Some words about to find the correct merging unit as a Bay unit. The dedicated Bay unit for the distributed busbar protection in the first step is the 6MU85. And I have, when I remember correctly, more than 50% of the audience already knows quite well the 7SS52 busbar protection system. And here it's maybe to make it easier, if you are used to configure a busbar protection system with a 7SS52, you can make the same the following approach. You are selecting a 6MU85 in the hardware standard variant HA1, and then you are adding 95 additional function points for the connection to the 7SS85 CU. And this device configuration is very similar like the small Bay unit of the 7SS52, the 7SS525. So it offers here 11 binary inputs, it offers 9 binary outputs, 4 CDs, means 1 current measuring point, and it also brings 1 PD module, which is mandatory for the communication to the 7SS85 CU. And as already said, that's the same like the small 7SS52 Bay unit, the 7SS525. If you are used more to the big 7SS52 Bay units, the 7SS523, then you simply add to this hardware variant HA1 one IO205 and 1 additional small display. And together, and with this hardware variant, you have it's the same like the big Bay unit 7SS523. One additional remark to this 95 additional function points you have to buy. With this 95 additional function points, you buy a flexible stream according IEC 61869, and this stream is suitable for up to 32 analog values, which means this is possible for up to 8 CDs. And in contrast to the Bay unit of the 7SS52, where it was possible every time only to cover 1 CD with the Bay unit of the 7SS52, with the 6MU85 or also with all other modular Cyprotec 5 devices, you can cover up to 8 CDs, 8 current measuring points within 1 Bay unit. Of course, you have to think about to add also more I/O modules to cover all these 8 CDs, but in principle it's possible, and you have to pay only 1 time this additional 95 function points. And with this additional 95 function points, you can send up to 8 current measuring points to the 7SS85 central unit. As already said, it's possible in the 7SS85 that each modular Cyprotec 5 device can be used as a Bay unit for the distributed busbar protection. So here in this example, I am using for a 7SJ85. So we have a 7SJ85. And what we need, of course, it's a distributed busbar protection. We need communication. And for this communication, we add this Ethernet BD communication module. And to activate in general the process bus functionality in a modular device, we have to pay 200 function points. And for the special communication to a 7SS85, we have to add further 95 function points. So all in all, to use a 7SJ85, to use a 7SL or a 7ST, 7UD, or whatever is available for a Bay unit for distributed busbar protection, you have to add the communication module, and you have to add 295 function points. And also here in this case, that's the same. You can use it for up to 8 current transformers, up to 8 bays for communication. So, last but not least, how to configure the 7SS85 IC61850 compliant distributed solution, which is using the centralized types of the 7SS85. It's a little bit a mix. So, how many bus sections must be considered? This answer, the 7SS85 is the same like the centralized busbar protection. So you have the same types, the same significant features available. So you have to answer how many bus sections must be considered. I have to answer whether is a disconnector image necessary. And it's the centralized busbar protection. So we once again need the base in the central busbar protection. So you have also to count for this approach the number of base. And also all these questions have to be answered for the central 7SS85. Is the N-fold protection very important? In this case, the N-fold protection has to be equipped in the central unit. It's not possible to make the N-fold protection in the merging unit in this case. The circuit breaker failure protection, do you need a circuit breaker failure protection? Here both approaches are possible. My recommendation is, whenever possible, to use in this solution the circuit breaker failure protection in the bay unit, in the merging unit. And this will be also, despite of the hybrid solution, of course, how many measuring points will be needed, how many measuring points are necessary. This question has to be answered for the bay unit. And how many binary inputs, how many binary outputs. This, of course, also as it is a distributed approach, must be answered for the bay units.